Hi guys, today is March 23rd and this is our math video for today. We're actually going to start with a do now, which is actually an activity we've done a lot in class. Give me a second while I switch it over and share my screen so you guys can see it. Let's see, share. Okay, so we're going to start with my favorite mistake. So I was going through your SBAC scores. I don't have everybody's SBAC scores. I don't have Mrs. Alonso's or Ms. Delgado's, but I was looking at mine, and for this question, we earned 58% as a class. But I'm just gonna remind you, we always shoot for 100%. And I was a little surprised to get that I saw that we had 58% on this question because we did so many questions with this type of question. We've answered several of these question types in class. So I want you to take a look at it. I want you to just notice. So we have a number line from 0 to 1, and we have some spaces in between, and we have A labeled on the number line, and it said to enter the fraction located at point A on the number line. So the first thing I want you to do is notice what the student responded with. They wrote 3, 6. And I want you to think about, what did the student do well? What do they understand? And then what is the student's misunderstanding? So you're gonna need your math notebook. Take your math notebook out, and you're gonna open it up to the next clean section, and you're gonna write, I think the student understands because . And then for student misunderstanding, I think the student's misunderstanding is because . So I want you to pause right now so that you can jot that down in your math notebook. All right, so you're back. You're able to figure out, like, what did the student do well and what they did not do well. So I'm gonna stop share of this screen so that we can go to, I'm gonna share this screen now. All right. So you might have written that the student understands how the numerator can be represented, because you might have counted off and noticed. So I'm going to use my pen over here so you guys can see. You might have noticed that there's 3 jumps. So the student understands that the numerator can be represented by the number of jumps on a number line, depending on where the point is located. And so we see that point A is located on the 3rd jump, and that represents our, I say, you say, love these words, say it with me, numerator, okay? However, you might have said that the student's misunderstanding is the denominator. I was very confused as to why they wrote 6 as the denominator. Because when we talked about it in class, we discussed how in order to determine the denominator, it depends on how the whole has been partitioned. And if you notice, there aren't 6 jumps. If you notice, there are way more than 6. So I'm going to continue jumping. So that's 4, 5, 6, 7. There's 8 jumps. In between 0 and 1, there's 8 jumps. And so the denominator really should have been 8s. And so the answer would have been 3/8. I also noticed another student wrote 1/2, which wasn't too far off, because 1/2 would have been here right down the middle, which would have also been 4/8. But it was definitely not 1/2. So you need to be careful when you're answering these types of questions. I also saw another student write a whole, which is very confusing, because you see that the number line is labeled in between 0 and 1. And so the A is not even near the whole, right? It's not even near the 1. So that didn't make any sense. Just make sure you're careful when you're answering these questions. So we're going to go back to our anchor chart. Let me get out of here so you guys can see it. I'm sharing this now. Okay. All right, so remember you say the word, I say the word, you say the word, and you just do the gesture with me. So say it with me. I'm gonna just make this bigger so you guys can see it better. Say it with me. Multiply, equal groups, number of groups, multiples, group size, factor times factor equals product, equation, commutative property. Remember, we've talked about commutative property. It doesn't matter the order of the factors. It's still going to give you the same product. So 4 times 2 is the same as 2 times 4. Associative property, very similar. It doesn't matter the order of the numbers. It's still going to give you the same product, specifically if you have more than 2 factors. So 3 times 2 times 2 is the same as 3 times 2 times 2, right? If I put 3 times 2 in parentheses, that gives me 6 times 2, that will give me 12. If I do 3 times 2 times 2, if I put 2 times 2 in parentheses, that gives me 4, and multiply that by 3, and it gives me 12. So we see that it gives us the same product. Say it with me, efficiently, and then a phrase I always want you to say. I think the product is because we have array, rows, columns, the word decompose, my favorite word, break apart, and distributive property is our newest addition. And we're just going to look at our models and strategies as we always do. I love repeated addition, skip counting, array model. Those are awesome. But we're trying to use or utilize even higher or better efficient strategies, right? So like we've talked about how decomposing is the same as distributive property. And you can break numbers apart so that you can multiply more efficiently. So we've already done our do now. We're going to talk about, I meant to write our learning intentions for today and I didn't. But our learning intention today is that we're going to deepen our understanding of the distributive property using an array model, which in 4th grade, guys, since I taught the 4th grade teachers, I was helping the 4th grade teachers, we call that in 4th grade the area model, and it's going to be your best friend in 4th grade. Success criteria by the end of our lesson, you can explain how the distributive model or the distributive property is represented through an array. Learning and language intention. I know we're not in class and you don't have the same speaking opportunities, but you can still say them out loud, maybe to an older brother, cousin, older sister. I say things, or I say words like distributive property, decompose, products, and factors. And our social intention, I do my work even when no one is looking. That one is important. This is for you. Remember, Ms. Maldonado knows all about the distributed property. Mrs. Alonso, Mrs. Delgado, we're experts. But you guys need to become experts. So make sure you're watching and you're trying at home. Okay, so we're going to continue with a partial products problem string. Again, you need your math notebook, and I want a whole page for this. And I did not have a lot of space on here to do it in one vertical column. I would like for you guys to write up at the top, partial products problem string. You're going to start with 5 times 3 equals n. I know you're probably like, Ms. Maldonado, I know what 5 times 3 is. I know. What we're really doing is we're going to look at patterns right now. So don't just disregard it because you know what 5 times 3 is. Just write it out because we're going to represent each of these equations with an array. So 5 times 3 up at the top, 5 times 10, 5 times 13, 5 times 20 at the bottom, and then 5 times 23. Pause me so that you can go do that right now. All right, so I am going to copy this partial products problem string into my Smart Notebook so I can write on it. So 1 second as I do that. I'm going to stop sharing this so that you guys can see the other screen. 1 second, where is it? Oh, here it is, okay. Okay, so pasting now. So we have 5 times 3 equals n, which we know we could do a table to represent with an array. 5 rows and 3 columns. And whatever I'm doing, you can do in your notebook. It's harder for me to write neatly on here, so you guys can try to write as neatly as possible. So I'm going to do 5 rows and 3 columns. So I have 1, 2, 3, 4, 5. That's going to represent 5 times 3. And I know you guys already know what 5 times 3 is, but we're going to write it down. We know that 5 times 3 is 15, so n equals 15. All right, we're going to do the second one. Another one that you probably know, and you're probably thinking, why are we doing this one? We already know what 5 times 10 is. We're still going to do it. So remember, we have 5 rows and 10 columns. I could do each box, but that's not going to be super efficient. So I'm just going to write 5 here, and I'm going to write here 10, right? And we already know that 5 times 10 equals 50. So we're going to write n equals 50. And I could just represent it this way, so you guys can see 5 times 10. And if I just write 10 with another color inside of each row, right? If we know that each one is 10, we know we have 5 groups of 10. Okay, so now we're gonna do 5 times 13. So, do I really wanna write out every single little box? That's gonna take me forever. But I can use the, say it with me, distributive property to show how to solve for 5 times 13 using an array model or area model. So watch. So I know I have 5 over here. I'm going to write 5 so I don't forget. 5 times 13, that's going to be harder for me. So what am I going to do? I'm going to decompose my rectangle. I'm going to decompose that 13 into a 10. And then I'm going to decompose the 13 into a 10 and a 3. Okay, now you're probably thinking, like, why is she doing that? So I'm going to use, remember we're comparing this back to distributive property using the array model. So I'm going to use my typing to type my distributive property equation. So I'm going to multiply to figure out 5 times 13. So 5 times 13 is the same as, in parentheses, 5, because look, I have 5 rows times 10. 5 times 10 plus, I'm gonna make this wider so you guys can see it. So 5 times 10 plus, in parentheses, 5 times 3. Let's make this a little bit smaller so you guys can see it better. Okay, and let's solve. Let's see what 5 times 13 is. We already know that 5 times 10 is 50, so I'm gonna write 50 over here in another color. And we know 5 times 3 is 15. And so 50 plus 15 equals 45. I mean 65, just kidding. So n equals 65. All right, so we have 65 so far. So that's 5 times 13 using our distributive property. Now we're going to do the same with 5 times 20. I already know what 5 times 10 is, so I'm literally just doubling it. So we're going to do, let's do this a similar strategy. Again, we're using an area model, array model to do this. I know this is going to be 5 over here. And I already know 5 times 10 is 50. I'm going to write 50 in the middle so I remember. And then I'm just adding another 10, right? I'm multiplying by 20. So this is going to be 10 as well. So 5 times 10 is 50. 5 times 10 here is 50. And so now I'm just going to add my products together, and that's going to give me 200. I'm going to use my typing so I can show you the equation for this. So we just said 5 times 20 5 times 20 is the same, or 5 times 20 is equivalent to 5 times 10 plus 5 times 10. All right, make sure you're writing with me as I'm doing this. And then our last equation from our problem string is 5 times 23. So similarly enough, I'm going to take another color. Let's do green this time. So I remember I have 5 on the side, and then I'm going to multiply by 23, but 23 is a larger number. And remember, in 3rd grade, we don't really do the algorithm yet. You're going to learn the standard algorithm in 4th grade. So we're going to decompose it. I'm going to decompose that 23 into a 20, because now we know 5 times 20 is 100. A 20 over here, and then a 3 to make it easy for myself. And I apologize, my rectangles look ugly. All right, so 5 times 20, we already know that's 100, and 5 times 3 gives us 15. As you're doing this, I want you to think, how efficient is the distributive property when you're multiplying a single digit by a double-digit number? How fast was that for me to use the distributive property to figure out that 5 times 23, right? We're going to find out the product right now. 100 plus 15 is 115. And let's do the equation so we can see the equation represented. So we have, let's make this a little bit smaller. So we said 5 times 3 is the same as 5 times 20 plus 5 times 3. All right, guys. So last but not least, I'm going to stop sharing the screen so you guys can see my Google Slides. Last but not least, you're going to practice in your math notebook. You're going to have some independent time using your Bridges workbook. Let me see if I can share this really quickly again. Share. Okay, so in your math notebook, you're going to, or your Bridges workbook, you're going to go to page 232 and practice these multi-step problems, and page 233. If you can, I would like to see you write me a comment on the YouTube video, underneath the YouTube video, and I want you to write, I think, let's make that bigger so you guys can see it better. I think the distributive property is an efficient strategy utilizing an array model because, and as a bonus, I'd love for you guys to solve this. So we just solved 5 times 23. So I'd love for you to use an area model, an array model to solve, using the distributive property to solve 5 times, let's do 46. 5 times 46 equals 10. Try to do that in the YouTube comment section. And remember, your parents can send me messages if you have questions, or you can email me. You know my email. I hope you guys are doing well.